Now that we've looked a little bit at the curl in R2, which was a scalar, we're going to start measuring the curl in R3. The curl in R3 is going to end up being a vector. So let's write down what the curl of F is in R3. So I start with my vector field F, and it's going to have three components because we are now in R3, an I, a J, and a K. So a curl of F is going to be a vector. Here's the I component. It's going to be the partial at F3 with respect to Y minus the partial at F2 with respect to Z. That's the I component. The J component is going to be constructed similarly. Oops, I put plus. I meant to put minus. It's going to be the difference of some partial derivatives. And the K component is also going to be the difference of some partial derivatives. The K component is going to be the partial of F2 with respect to X minus the partial at of F1 with respect to Y. So when we look at the construction of these partial derivatives, the I component, there's a partial with respect to Y and a partial with respect to Z. One way that we can try to remember this so that we don't have to sit down and memorize all these things, because like I said, like I've said before, I've never asked you to memorize things, but we might have to remember some stuff, is if we look at the partial derivatives that we're looking for in the I component, we have a partial with respect to Y and a partial with respect to Z, the ones that are not the I direction, because we want to know what's going on, what's happening to the I component as we change the Y and as we change the Z, just like we did in the scalar curl. We take the partial of F3 with respect to Y. So this is similar to the scalar curl when we did the partial of F2 with respect to X, because F2 is in the J component, and we did the other one, X, over here. So if we look over here, one way we can interpret this is like nothing matches. So we're never going to do the partial of F2 with respect to Y. There's a partial of F3 with respect to Y. There's a partial of F2 with respect to Z. And these are all the ones that are I. There's no F1 here. There's no dx. Look in the K component. The K component in the vector field is an F3, but we're using F1 and F2. The K component is a Z thing, but we're using X and Y. So in the J component, we should see F1 and F3 and a dz and a dx. And they shouldn't match. There should be a partial of F1 with respect to Z and a partial of F3 with respect to X. So the way I try to remember the curl is nothing matches. So it's the partial of F1 with respect to Z minus the partial of F3 with respect to X. Then we might start thinking, actually pause for copying. Give people a chance to copy this. I don't like memorizing formulas, but I do like looking at how everything is getting put together. And when I look at all the partial derivatives that we have here, I think about summarizing it by saying nothing matches. There's no partial of F1 with respect to X. That one doesn't show up. I have a partial of F1 with respect to Y and a partial of F1 with respect to Z. But the F1s don't show up in the I component, even though F1 is in charge of the I component, because we're looking at the curl. And so nothing matches. There's no partial F2 with respect to Y. There's a partial F2 with respect to Z. There's a partial F2 with respect to X. And F2, even though it's in charge of the J component, the partial F2s show up in the I and the K components. When we see which one is which, the partial F2 with respect to Z shows up in the I component, and the partial F2 with respect to X shows up in the K component. I is normally an X thing, but there's the partial with respect to Z. K is a Z thing, but there's the partial with respect to X. And similarly for F3. So the way I think about remembering the curl is nothing matches. Any questions? Here's one other thing. So this is how I remember things. Nothing matches. That's how I remember which parts go with which. Here's the other thing that I notice about the curl, and why I both like representing it this way that I've written, and I don't like representing it the way that it's written. So notice these are all based on subtraction, and in subtraction, the order matters. So the partial F3 with respect to Y, we're looking at differences, but we care about which one is the minuend and which one is the subtrahend. So partial F3 with respect to Y minus partial F2 with respect to Z. Partial F2 with respect to X, partial F1 with respect to Y. Oh, look, it looks like we're going in order. Y, Z, and then X, Y, and then Z, X. Ah, dang it. J, come on, what's going on? And here's what's going on. This has actually been simplified, and you know how I hate simplifying things. Well, I don't hate simplifying things, but it hides things when we simplify it. If I factor out a -1, I have the partial F3 with respect to X minus the partial F1 with respect to Z in the J direction. And now it's YZ, XZ, XY. Now they're all going in order. So I also remember this by thinking that the middle one, is out of order because it's ZX. Here's why I think that. Here's why I remember it that way. So here we have YZ and then XY, and then this one, we want to write it XZ, but heck, it's written ZX. But it's also written with plus out here, because the pattern that's going on is that this one is plus, this one is minus, and this one is plus. This is because it comes from, we could think about this as coming from a determinant. We can think about this as coming from a determinant, so it's like the middle one is negative. We remember calculating a determinant by cofactor expansion. So if we remember it that way, then we just put everything in order. In the I, we have the partial YZ, then XZ, but it's negative because determinants, and then XY, and the last one's positive. So that's why the middle one to me looks backwards. So the middle one to me looks backwards. YZ in order, XY in order, ZX, what the heck, not in order. But if we make a negative, XZ, now it's in order. And if we think determinants, that's how we can remember that. Any questions? All right. So we're looking at a vector. We're looking at a vector. And we're also looking at determinant. So what do vectors plus determinant equal? What must we be looking at when we're looking at the curl of F? This is where the author of The Mystery is really wondering if you put the right clues out there. Curl on R2 is a scalar. Curl on R3 is going to be a vector. We have the nothing matching going on. We have the middle one was out of order until we factored out a -1. And then we got a vector and the middle one's negative. That's something that happens in determinants. That's how we'll remember that the middle one is out of order. So we got a vector. We got determinants. And none of the things go together. F1 is supposed to go with I in the vector field, but the I component of the curl does not have any F1. X is supposed to go with I in the vector field, but we have nothing in the I component of the curl with a partial with respect to X. So we got vectors, determinants, and nothing matches. What does that tell us this curl in R3 must be? Right. Let's pause the video here because that is the question I am not going to be answering. Not today, anyway. You see what it is, and this will solve all the problems. What it is